Okay, so for problem 6, we're trying to prove these statements here. And for item 8, we're trying to show that the intersection of B, which is just some set, right? So we're saying let B be a set. The intersection of B with the union of the family A, and this family has all these sets, capital A, which are indexed from this set delta. So we're saying, hey, the intersection of B with the union is equal to the union of B intersected with the sets from the family, right? So what we're going to do here is we're going to take some element that is here and show that that element is also there. But we're going to do it using if and only if statements, because the thing with if and only if statements is we can go backwards, right? So if we take some element that is on the expression on the right and show that it's on the left, it also means that we can take some element that's on the left and show that it is here. So we're going to do that. So we're going to say we have that. So we're taking some element from this guy right here. So of B intersected with some set in that family, right? So now what we're going to do is we're going to unwrap the meaning of X belonging to the union of this stuff. So if X belongs to that, if and only if X belongs to the intersection of B with some set A that is indexed by little a, right? So it can only belong to the union if X belongs to the intersection for some A belonging to delta, right? So we unwrap the meaning of the union, and now we're going to unwrap the meaning of this intersection. So we're going to say this is true if and only if X belongs to B, and because that's the meaning of intersection, it has to belong to both, and X belongs to A sub A for some to delta. So we first unwrapped the union and then we unwrapped the intersection, and now something interesting happens where when we unwrapped it, this is quite literally the definition for X belonging to the union of the family, right? So because that definition showed up, we can now say if and only if X belongs to B, so that stays the same, and as we've previously mentioned that this is the definition of the union of the family, so we're going to say and X belongs to the union of the family. And now if because we had X belongs to B and X belongs to the union, and now we're just going to join these into an intersection, because an intersection is the same thing as saying and. If and only if X belongs to B intersection with the union. So that is it. We took some element that was here and then showed that it must be there. So it means that the union is a subset of B intersection with union. But because we used if and only if, we could also, from this, we can begin saying that X is here and then reason backwards to show that X must be there. So we have completed our task for item A. And now let's do item B. Item B is kind of similar, but now we're going to, wherever we had an intersection, we're going to have a union, and wherever we had this, and vice versa, right? So what I'm going to do here is I'm going to utilize, let me just change this here. So we're going to begin the same way, where we're going to let X be over here, and then we're going to unwrap the meaning of the intersection and the union, and then show that X must be here as well. So we're going to say we have that X belongs to the intersection of A belonging to delta of B union. So now let's unwrap the meaning of this intersection if and only if. So for the union, we said that, okay, X belongs to this thing here for some A belonging to delta, but now because it's an intersection, it has to belong to all, right? For all A belonging to delta. If and only if X belongs to B union for all A belonging to delta. So that's the biggest difference between intersection and union. And now we're going to unwrap this union over here. So if and only if X belongs to B or X belongs to A sub A for all. So in this line over here, we unwrapped the intersection, and then in the third line, we unwrapped this union. And then from here, we're going to say if and only if. We're going to repeat this X belongs to B. But now this thing right here is the definition for the intersection. So if X belongs to A sub A for every single A belonging to delta, it means that X belongs to the intersection of the family. So by unwrapping, we ended up having that definition for the intersection showing up. So we say or X belongs to the intersection of A belonging to delta of A sub A. And now, since we have X belongs to B or X belongs to the intersection, we're now going to join these into a single expression by turning the or into a union, because it's the same thing, right? So if and only if X belongs to B union the intersection of A belonging to delta of A sub A. Okay, and that is it. So we took some element that was here, and then we reasoned that that element must have been here. But because we used if and only if, we could have just as easily started here and then worked backwards and then shown that that X must have been there. So the if and only if statements, they show a double inclusion, and therefore these statements are equal. And that is it for item 6.